multiplication of a vector by a scalar. Okay, for a vector k and then vector a, so this would be the scalar, where k is a scalar and vector a is a non-zero vector. If k is greater than 0, then what happens is a is in the same direction with the magnitude of course, like whatever the magnitude of like the vector is originally, times k. Okay, and for k is greater than 0, two different possibilities will be considered and are illustrated here in this diagram. Okay, so it's going to be one of two things. So if k is between 0 and 1, what's going to happen is the vector is going to be same direction but shortened. If k is greater than 1, the vector is going to be in the same direction but lengthened. Okay, for example, we can have like 1/2 of vector A, so the magnitude of 1/2 vector A is going to be equal to 1/2 of the magnitude of vector A. Okay, and then 3/2, which is of course greater than 1. This is k equals greater than 1, or 3/2 is greater than 1. Okay, the magnitude of 3/2 of vector A is going to be equivalent to 3/2 of the magnitude of vector A. Okay, same thing. Okay, on the flip side, if k is less than 0, so all that's saying is like it's going to be a negative number. What it's going to happen is now our vector k, vector A, is going to be in the opposite direction. Okay, and it's going to have a magnitude of whatever k is times the magnitude of vector A, and of course it's going to be positive. Okay, because magnitude is always positive. So again, here are the two situations. So if it's multiplied by a fraction of, like a negative fraction, is going to be a fraction of the magnitude. And if our vector is multiplied by a negative but greater than 1, it's going to be lengthened, but again in the opposite direction. Okay, so you can just read this for clarification. So example 1, an airplane is heading due north at 1,000 kilometers an hour. The airplane's velocity is represented by vector v. Draw the vectors negative vector v. So if this is vector v here, negative vector v is going to be this is vector v, so it goes north. So negative vector v is going to go south, negative vector v. That's pretty easy. And just the scale on this is like, say, 1 centimeter is equivalent to 250 kilometers an hour. So we're just drawing like 4 centimeters, right, for 1,000 kilometers an hour. But for 1/2 of vector v, we're actually just going to draw 2 centimeters. So same direction as vector v, but the magnitude is going to just be 1/2. Okay, and negative 1/2 of vector v, again, going opposite direction. So the negative represents the opposite direction, and 1/2 represents 1/2 the magnitude of vector v. Okay, so here are some special cases. When k equals 0, so basically if we multiply any vector by the scalar 0, then it's always going to result in a 0 vector. So this is how we denote a 0 vector. And when k equals -1, what's going to happen is the magnitude is going to be unchanged, but the direction is just going to be opposite. So for example, 4 times vector A and -4 times vector A, these are going to have the exact same magnitude, but they're going to be opposite directions. Okay, so here's just an example. This right here is your baseline. This is your vector A. Okay, so negative opposite direction, obviously this is going down, and then 0.7, that's going to be shorter. Negative going down, 0.2, even shorter. Okay, negative going down, but 21/10 is greater than 0. Or sorry, greater than 1, so it's actually going to be longer. Okay, and take a look likewise for these ones here. Right, collinear vectors, we talked about this before. This is when two vectors are parallel or lie on the same straight line. Okay, they are collinear since they can be translated so that they lie in the same straight line. Okay, they can be translated. Vectors that are not collinear are not parallel. Okay, when discussing vectors, the terms parallel and collinear can be used interchangeably. So two vectors u and v are collinear if and only if it's possible to find a non-zero scalar k so that they become multiples of each other. Okay, vector u is some multiple k of vector v. Okay, let's go example 2. The vectors vector x and vector y are unit vectors. So when you see unit vector, all this means is they have a magnitude 1. We're going to get more into that shortly. Okay, they make an angle of 30 degrees with each other. So for example, okay, if this is x and this is y, that's fine. Magnitude is 1, magnitude is 1. And they make an angle 30 degrees with one another. Remember, the angle is tail to tail. Okay? Calculate the value of 2x minus y. So 2x would be this long. Okay, so the magnitude would be 2 this time, so 1 and then 1 again. So essentially it'd be 1 and 1 again, and then minus y. So the y usually goes down, so instead this time the y is going to go up. Okay, so this is going to be minus y. Again, magnitude of negative y is just going to be 1. Okay, and we want to find the magnitude because these bars here, we just want to find the magnitude. So originally, this angle, these two angles would be 30, and then the angle in here would be 180 minus 30, so it'd be 150. I'm going to actually draw this just really quickly bigger. Okay, so this is going to be 2x, and then usually this would be y. Okay, and that would be 30. But now we're going to go backwards here. Okay, so this is negative y. So let's put this onto here, draw our parallelogram. Because this is going to be 2, this is going to be 1. Okay, and in the original drawing, this was 30. Okay, tail to tail. But now this is going to be 30. And I'll show you why. Grade 9 Z pattern. Okay, so the Z pattern's here. It goes down, and then it goes across. So we have, essentially we're dealing with 2, 1, and then 30 in between. I'm going to use cosine law. Let's call that A. Okay, A squared equals B squared plus C squared minus 2BC cos A. So we have A squared equals 1 squared plus 2 squared minus 2, 1, 2 cos 30. A equals. So 1 plus 4 minus 4 cos 30. 1.5 and then 1.5 and then root them. A equals 1.24. Okay, so 2x minus y, the magnitude of that equals 1.24. Now if we're looking for the direction, let's talk about this direction here. So we can use the sine law. So let's go sine 30 over 1.24. Okay, because those two, this 1.24 and this 30 match up. And then that's going to equal sine of, let's call that b, over 1. So sine 30 divided by 1.24, I get 0.40 equals sine of b. Now let's sine inverse both sides. That goes away. Okay, b equals 23.78. Let's just round to 24 to make life easy. Okay, so this angle in here right now is 24 degrees. And just as a review, we can't just put 24 degrees, we have to put it relative to something. Okay, so let's say the magnitude is 1.24 and our resultant is 24 degrees rotated this way right here. So that's counterclockwise. So counterclockwise from, what's this, to vector 2x. Okay, example 3, an airplane flying in the direction of north 30 degrees east. Okay, so I always draw this in the side of my paper. So we're going to start north, and then we're going to go a little bit more east. And that's at an airspeed of 240 kilometers an hour. Okay, so this here would be 30 degrees from north, 30 degrees east. The velocity vector for this airplane is represented by vector v. Okay, so we're just going to name this one right here. This is going to be vector v. Okay, draw a sketch of 1/3 of v and state the direction of the vector. So I'm actually going to draw that right then. Okay, so 1/3 of v is going to be right here. So this is going to be 1/3 v. And what I'm actually going to do is I'm going to extend this. Let's do negative 1/3 v. So of course, drawing the opposite vector, like this is right here, negative 1/3 vector v. Okay, that part's easy, but the direction is a little bit more difficult. So we know that this is 30 degrees here. So let's call this never eat. Okay, so let's say negative 1/3 of v, the direction of negative 1/3 v is going to be south 30 degrees west. Okay, now for b, for the vector 3/2, so 3/2 of vector v, state its direction and magnitude. So if we have 3/2 of vector v, if we're talking about the magnitude, we're actually doing 3/2 of 240. Okay, so it's 240 times 3 divided by 2, or just times 1.5, and we get 360 kilometers per hour. Okay, and the direction is going to be the same, 360 kilometers an hour, north 30 degrees east. So it's useful sometimes to multiply the non-zero vector, vector x, by a scalar 1 over like the magnitude of vector x. Okay, this does say magnitude, it's really small. But when we multiply vector x by 1 over vector x, or the magnitude of 1 over vector x, we get the vector 1 over the magnitude of x times vector x. Okay, this vector is of length 1 and called a unit vector. Okay, I might be saying this wrong. Let me repeat this. 1 over the magnitude of vector x times vector x. That's how we say it. Okay, and this points in the same direction of vector x. Unit vectors are useful in application of vectors. You're going to see this come up again. Okay, so for example, we have vector x right here, and the magnitude of that is 3. So if we were to multiply it by 1/3, we'd get a magnitude of 1. Okay, like let's see an example of that. For example, 4. The magnitude of vector u equals 4, and the magnitude of vector v equals 5, and the angle between vector u and vector v is 120. So let's just draw that. So we have vector u, which is 4, and then vector v, which is 5. Let's put magnitude here. And then this angle is 120. Again, that's tail to tail. Determine the unit vector in the same direction as u plus v. So I like the parallelogram. You guys might not agree. That's okay. You can use the triangle, but I'm going to do from here to here. This is going to be that's our u, vector u plus vector v. Okay, we must determine the unit vector in the same direction. So first, let's just solve using the cosine law. Okay, so this was 120. That means this is going to be 180 minus 120. Okay, it's going to be 60. This is 60 degrees between the two, head to tail. So let's do, of course, let's call this A for simplicity. A squared equals B squared plus C squared minus 2BC cos A. A squared equals, we got 4 squared plus 5 squared minus 245 cos 60. So we get A squared equals 16 plus 25 minus 8 times 5 is 40 cos 60. We get 21. So let's root both of those. A equals, let's just leave it as root 21 so it's exact. Okay, so what we're actually going to be doing right now is we're going to be multiplying vector u plus vector v by 1 over root 21. So we can just simply rewrite this as 1 over root 21 vector u plus 1 over root 21 vector v.